see here few ICs and some on the right hand side. So we have to understand what is it exactly and what does it do. So please remember, integrated circuits are very essential and very important part of any of the circuit. Electrical, electronics, you take it anything, it is very important part. It was a big revolution when the integrated circuit came into existence. Like transistors, we have already discussed before, that was also a big revolution. But here, the integrated circuit was a bigger than that revolution. That is, the whole circuit has been put into a small piece of chip, right? What chip? It is a wafer, we call it as a very thin wafer on which all the circuit, that is transistors and other components, it is placed and it has been made in that way. Okay. So please remember, it is an active component. Why we call it as active component? Why? Because when the current is given, when the material, when the supply is given to it, then only it will start working. Otherwise, it won't work. Secondly, it is made up of what material? Silicon, right? It is made up of silicon material, or rather we can say silicon wafer. It is made on a silicon wafer. Okay, right. It can be from 3 pins. That means the number of pins to it, it can start from 3 pins and it can go up to many pins. That is, if it is a microcontroller, somewhere you will find a pins of 200, 250 also, more than that also. Okay, so different packages of ICs is available. You can see 3-pin ICs are mainly, you can see not transistors, but it is called as regulator IC, power regulator, linear power regulator ICs, or regulator IC. Okay, so microcontrollers, memory IC, all these comes under the digital IC. We'll study about that. So that comes under digital IC. Okay, so this is about a IC. Little explanation I've given you about IC. It will have different number of pins. Notch, there will be a notch on the left hand side of the notch, that is anti-clockwise. You have to count the pins. Okay, now we'll go to the next one. That is called as IC package, right? Like in transistor, here also, the different packages will be there. What is packages actually? The packages are shape, size, and the number of pins. Different shape, size, and number of pins. Like that will make into a package. So like in transistor, we have studied 3-pin, that is TO92, 220 package. Here also, in IC also, you have the same. That is TO92 and 220 package. That is 3-pin. Input, output, and ground. Okay. So likewise, if it is more than 3, it can be 8-pin IC, like 555 or operational amplifier, which will have 8 pins. Dual in line, it can be 14 pins, it can be 18 pins or more than that, right? So we have different packages and different sizes of IC decided according to their shape, size, and pins. Example, you can see on the slide, you have a pin grid array, right? The microprocessor and microcontroller, which will have a pin coming out. We got a pin grid array. Then you have SOJ, QFP, quad flat pins, small J lead pins. That is, if it is to be soldered on the same side of the board, right? SMD board, then we use SOJ or QFP packages. Nowadays, the latest are the BGA, right? That is called as ball grid array. You will not find the pins, but the pins are on the bottom side of the IC, and which are a ball of lead which get fixed on the board itself. Okay, right. So this is about the packages. Now, types of function of ICs. This is very important. Again, I told you, you can see on the right hand side, there is a small silicon die chip. The package is the bigger size, that is will contain the pins and the plastic area. But the actual chip is a chip, that is silicon chip, which is there on the center. You can see it here. It is there in the center. Okay. So this is very important. I told you there is a notch here. The notch is there on left hand side. This pin, this one, we will take it as the pin number 1. This will be pin number 1. Okay. Right. Now we'll come to types, or we will come to function of the ICs. So you have analog ICs, you have digital ICs, you have mixed signal ICs. These are the 3 basic ICs what we should understand. What is analog IC? Operational amplifier, voltage regulator, analog multiplexer, and demodulators and duplexers. These are not duplexers, the demodulators. So these are analog IC. So all power regulators are analog. Then you come to digital IC. You know about digital IC, binary zeros and ones. So logic gates, very, very important. Digital ICs are are the backbones of today's electronics and electrical backbones. So digital IC, zeros and one. Logic gates are the example, different type of logic gate, and or NAND you will study, or rather you know. Then you have flip-flop circuit, microcontrollers and microprocessor, and different type of shift register ICs will be present in the digital form. Then the third category is mixed signal IC. Mixed signal means combination of digital as well as analog, right? ADC, DAC, ADC is analog to digital converter, DAC IC is digital to analog conversion, where you do the conversions, analog to digital and phase loop. The simple example, mixed signal IC is a timer IC, that is 555 IC. Okay, it's a mixed signal IC. Please remember that. Okay, we'll do some practicals related to this in the later part. Linear ICs, right? Maximum in the beginning, when the integrated circuit came into existence, we were having all linear ICs only. So audio amplifier, we used to have linear IC. Audio processing, pre-amplification, power amplification, you have audio, we used to have linear ICs. So audio and voltage regulator, that is power related. We will be using mainly what type of IC? Linear ICs. That you have to understand. Digital IC, where do you use it? Computer, data processing, control system. That's why I said the revolution has come after digital IC, right? Okay. Communication ICs, these are the functions where the ICs are used. Please remember this. So power we will use, communication we will use, programmable ICs will be there, memory ICs will be there, where we can store the digital data inside the IC. Then you have sensor IC, different type of sensor ICs. This will be present in this thing. So where we use this ICs, these are the area. Almost everywhere, all the work is done, or you will get all type of IC in the market or in the circuit where you can do all the work, from power supply regulation, for amplification, for oscillation, for memory, for digital, for communication, everywhere, all levels we use ICs. Okay, right. Now we'll come to the next thing that is very, very important, level, that is integration level. Now on integration level, there are 4 basic integration levels, right? Okay. SSI, that is small scale integration. Beginning, where we use, if it is a digital, it will be having 10 to 100 gates or transistor. Please remember, integrated circuits are made up of gates and transistor. More number of transistor, more number of gate, that will decide the level of integration. So first came the small scale integration. We call it as a SSI, a few transistor or gates. Then came the medium scale integration, MSI, where 100 of gates or simple chip on a single chip, right? Or transistor we use. Then came the large scale integration, LSI, thousands of gate, correct? Thousands of gates and transistor. After that came, which is existing now, maximum microcontroller or microprocessor, or based on that, we call it as a very large scale integration. That is VLSI. You must be having, you have a big study on this. That is VLSI design, where we can integrate or we can make a different type of chips, or we can manufacture the chip, right? That is called as very large scale integration, where you have millions of gates and transistors, right? Then the future this came to is large scale, ultra large scale integration, ULSI, ultra large scale integration of transistors. Okay, so these are the integration level. Finally, how to test the IC? See, please remember, like other components of active and passive groups, we have tested mainly on multimeter, analog or digital multimeter. But here in ICs, you cannot check with the help of the multimeter, except 3 leaded, that is regulator IC. You can somehow you can check on the with the help of a multimeter, but more than 3, if it is a 5-pin, sorry, if it is a 8-pin or it is 16-pin IC, you cannot check with the multimeter. Okay, what you can do with the help of a multimeter, whether the supply voltage is correctly given to the pin numbers of the IC, you can check with the help of a multimeter. If it is short, if the supply is given and the supply immediately drops, that you can check with the help of a multimeter whether the IC is working or not. Second important thing, you can just put your finger or your hand as shown in here in this picture, right? And you can just see whether what is the heat, amount of heat generated on this thing. If the heat is exuberant, that is more than expected, immediately that shows that the integrated circuit has failed. Third important point, With the help of an oscilloscope, you can check the signal waveform input and output, what we are supposed to get from that integrated circuit. Okay. And very finally, there is a digital IC tester. But in the IC tester, you can check, it will tell you, but very few ICs will work on that. Not all the ICs will work on that. So please remember the physical checking heat, the supply voltage, that is very, very important. That I will show you practically in when we do the practical session. All right, friends and students, I will just show you a few of the ICs, which I've just kept it here. First of all, this is 8-pin IC, which I'm trying to show to you. This is 8-pin IC. That means dip IC for this side, for that side. Okay. So first, what you have to remember, how to count the numbers, pin numbers. So there is a notch here, notch you can see on this corner. So left hand side, that is, this side is pin number 1. Then so on, it will come up to 4, 5, 6, 7, and this will be the last pin. Okay, pin number 8. Okay, it is fixed on a base. What base? This is IC base. Like IC base, I'm just showing one more IC base. Like this is also an IC base. Okay, this is fixed on PCB. I can take it out. The base I can take on the base. Then we'll fix the IC. Okay, this is how many pin? 14 pin IC. Okay, but the base is a little bigger. But I just wanted to show it to you. Right here also you have a notch. Correct? Notch. So I said left hand side. So this is pin number 1, 2, 3, 4, 5, 6, 7. Right? 8 comes over here. Right? 9, 10, 11, 12, 13, 14. Okay. Right. So how you will see the bases are different and this IC is different. Okay. So first of all, I told you how you will check whether the IC is getting heated up. Just put your finger on that after giving the supply. After giving the supply, you check it. And if it is, you find that it is getting extremely heated up, then the IC is probably shorted out or there is a short circuit in the IC. Okay. Right. So this is 2 ICs I've just shown you. I will show you some BG ICs. Right. This is mobile phone board. Okay. This is mobile phone board. So on this mobile phone board, I will just try to show it to you. ICs, these are the ICs, whatever I'm putting my this thing. 1, 2, 3, this bigger IC. One is microcontroller, microprocessor. These are the bigger ICs. Now in this ICs, you don't find pins. Can you see the pins? No, you cannot see. Why? Because the pins are on the bottom side. Bottom means it's the IC inside, like the bottom area is having the pins. That's why the pins are not to be seen. This type of IC we call it as a BGIC. BGA, ball grid array. Okay. So just wanted to show you few of the ICs, smaller size ICs are also there. So nowadays, in today's technology, we will deal with SMD ICs, that too BGA one, that is ball grid array IC. Now, we will take one example. I have just kept it here. I have made one circuit and I will just show you with the help of meter. I'm giving supply to this particular circuit. It's a 555 timer circuit. So 555, a stable multi-vibrator circuit. I'm just giving you a little idea about it. So I will just put this here and I will try to show it to you. Okay, right? Right. Now you can see the circuit is working well because the LED is green. So how to test it? How to test this circuit? So I told you how to test the IC. Please remember, wherever the supply pin is going, you have to check whether the supply is all right or not. I have given a supply of approximately 8 to 9 volts from here. So I will just check whether my supply is okay. So this black pin, I'm putting out on ground. You have to put it on voltage range and it is going to pin number 8 of the IC. So I'm getting 8.11. Okay. And also it is going to pin number 4 of the IC. I've kept it on pin number 4 of the IC also, same 8.4. If suppose this supply of 8 volt drops to 5 volt or 4 volt, that means the IC is gone. Okay. This is the way you check it. Okay. Ground pin and the supply pin. Second is you just put your finger on this IC. See whether it's getting heated up. No, it is not getting heated up. That means my IC is working. This is one linear IC. That is, we call it as a regulator IC. I will show you this also. So I will put one input supply to this. The pin number 1 is the supply. Okay. The pin number 1, I'm giving the battery supply, and pin number 2 is ground. So I'm giving ground supply. So here you can see pin number 1 is the supply, input supply, pin number 1, second is ground, and third is output. So this is a regulator output regulator IC 7805. 5 volt positive regulator IC. So how to check this IC with the help of this? First of all, I will just put it to ground. This pin I will put it to ground. The center point was ground. Okay. So this is ground. I will check whether the input is approximately 8.37. Let's check the output. Okay. So let's check the output. So output is coming to around 4.88 or approximately 5 volts only now, right? So I'm getting 5 volt output. So my regulator IC is working okay. Again, the heat, right? I'm just testing. I'm just putting my finger on this IC. It's not getting heated up. This IC, regulator IC, is also working. So we have checked these 2 ICs. We'll discuss about the circuits and how to make this in the later classes.